Okay, find your 3.2 notes, please. This is a review from Algebra 1. The substitution method. There are 4 steps to help you. Step 1, solve one of the equations for one of the variables. Step 2, substitute the expression from step 1 into the other equation and then solve for the variable. Step 3, substitute the value from step 2 into the revised equation from step 1 above and solve. And step 4, write your solution as an ordered pair. Let's also put another note here. When you want to choose substitution, you want to look for a coefficient of plus or minus 1. That's going to be the variable that you want to choose. So, in example 1, I have 2x plus 5y equals negative 5, and x plus 3y equals 3. So, if I tell you that we want to look for a coefficient of plus or minus 1, and then that's the variable you want to solve for. So, Henry, what variable do I want to solve for here? The x in the bottom, exactly. So, all we're going to do is we're going to subtract the 3y and get x equals 3 minus 3y. That's our step 1, solve one of the equations. Then you're going to go plug that into the other equation. You don't go plug it back into that same equation. So I'm going to take 2x plus 5y equals negative 5, and I'm going to replace the x with 3 minus 3y. Now looking at this resulting equation, what did that do for me? When I substituted for the x in my new equation here.
There's no extra to find right now.
Good job, good job. Now there's only one variable. I can solve it, but when I have 2x plus 5y equals negative 5, I can't figure that out. But if I can get down to one variable, I can figure that out. So I've got 6 minus 6y plus 5y, so I'm going to use the distributive property. I'll collect like terms. Then let's subtract the 6, and I get negative y equals negative 11. So y is 11. Then all you're going to do is go plug it in right here. This one's a super easy one to do to find x. X is 3 minus 3 times y, but y is now 11. So x is negative 30. Now, Megan, what is step 4? What does step 4 say?
Write your solution as an ordered pair.
Write your solution as an ordered pair. So we're going to write that that's negative 30, comma 11. And what I want to do here is make a connection to what we learned yesterday. Yesterday we worked on solving systems by graphing. And if you recall, we had 3 situations. We had where you had 2 lines that intersect and we got 1 point. We had parallel lines that had no intersection and there was no solution. And then we had 2 lines that coincide and there were infinitely many solutions there. So when we're solving these algebraically, I need you to begin to make connections to the graphs. Doing things algebraically, graphically, numerically, those are big connections for what we need in calculus. So what situation out of these 3 do I have when I get the ordered pair negative 30, comma 11? Graphically, which situation is that? The first one, right? This is actually, when you get an ordered pair, it's the situation where you have, it was intersecting in 1 point. So when you're solving these, I need you to really stop and think, what's going on? What does this mean? Okay, it's very, very important that we're doing that. Okay, so substitution, you guys remember that, right? From Algebra 1? Okay, good. Elimination method. Multiply one or both sides of the equation by a constant to obtain coefficients that differ only in sign for one of the variables. For example, in my top row I might have 2x, and in the bottom row I'd have negative 2x. So that's what it means by it's the same number but they differ by a sign. Step 2, add the revised equations, and it's going to eliminate one of the variables. That's why it's called the elimination method. Once you do that, you'll be able to solve for one variable, plug it back in. Step 4, write your solution as an ordered pair x comma y. So in example 2, if I want to solve this system, 3x minus 7y equals 10, 6x minus 8y equals 8. All right, anybody willing to pick a variable, and what would we multiply by? Sometimes you multiply one or both. Yeah, Jaslyn?
You can multiply the top one by -2.
Okay, if I multiply the top one by -2, I get negative 6x plus 14y equals negative 20, and be very careful with those minus signs. And then do you see how in the previous screen I had the 2x and the negative 2x? Here's our negative 6x, 6x. You're looking for the same number. Sometimes you can get away with multiplying one equation. Sometimes you're forced and you have to multiply both. Now let's add these together. I get 6y equals negative 12. Divide by 6. Y is negative 2. Now it's your choice. You can pick the first equation or the second equation to find x. I'm going to go ahead and just use the first equation. And I'm plugging in that y is equal to negative 2. So I get 3x plus 14 equals 10. 3x equals negative 4. Divide by 3. X equals negative 4/3. So Hannah, what was step 4? Awesome. Okay, the last thing you want to do is make this an ordered pair. And then McKenna, what situation graphically is this? Is it two lines that intersect in a point, two parallel lines, or lines that coincide?
Two parallel lines?
What would be the solution if they're parallel? Andrew, can you help her? Or anybody? If they're parallel lines, how many times do they intersect?
None.
None.
No solution.
It's no solution, okay? So it can't be remember, their intersections are the solutions. And you guys, I really, really, really want to encourage you that making mistakes is not a bad thing. Making mistakes is a wonderful thing. That's for us to go, no, wait a minute, what's going on? And so then we just made a wonderful connection in our brains, okay? We made a connection with, okay, the solutions to a system of equations is how many times or where they're intersecting. If they're parallel, wait a minute, they don't intersect. So it's not that situation. Andrew, then what situation is that? Graphically. Do they intersect at a point or do they coincide? They're the same line. All right, Carmel?
They intersect.
They intersect in one point, okay? And this is good, you guys. This is very good. It's okay. I'm not trying to make anybody feel bad. That think about this. In order for them to have one point, they had to be intersecting with one x and one y. If they're the same line, it has infinitely many solutions on there, okay? All right, now, there are a lot of wonderful applications to systems of equations. So let's look at example 3. To raise money for new football uniforms, your school sells silk screen t-shirts. Short sleeve t-shirts cost the school $5 each and are sold for $8 each. Long sleeve t-shirts cost the school $7 each and are sold for $12 each. The school spends a total of $2,500 on t-shirts and sells of them for $4,200. How many of the short sleeve t-shirts are sold? So let's let X be the number of short sleeve t-shirts. That's what they're asking us to find. But what is the other unknown here? Elena, what's the other unknown?
You don't know how many long sleeves are short.
All right, we also don't know how many long sleeve t-shirts we have. And something I want to point out, two things actually. One, make sure you identify what your variables are. It's going to help you mostly, but then it will also help me when I look at a quiz or a test or your homework. But it's important to know, what do your variables represent. Tied into that, secondly, is X is not short sleeve t-shirts. It's how many you have. It's the number of short sleeve t-shirts. That's important. I know that sometimes students are careless with their variables, and they'll just say X equals short sleeve. Well, X isn't short sleeve, it's how many. Does that make sense? What I'm saying is actually very, very important. All right, does somebody want to attempt a system of equations to describe this problem? Anybody want to try it? Yeah, Henry?
5x plus 5y equals 4,200 because it's the number of t-shirts you sell, correct?
Okay, wait a minute, you lost me. Okay, you said 5x, which would be 5 times the number of short sleeve.
Right.
Now that's how much the short sleeve t-shirt cost the school. But 4,200 is how much
right.
the school sells
So
them
it would
for.
be
8y equals, and how much did the school pay for them?
20,000.
2,500. There you go. All right, and then now we've got how much they're selling them for. So now can you give me the second equation?
Would be
7x plus 12y equals,
No, it's
Would it be
eight.
7? It would be 5 and 7,
Yeah.
and then 8 and 12.
that's what I'm
Because
confused about.
the t-shirts cost the school $7.
oh, and then they sold them.
And
Yeah,
they
yeah,
sold them
You're
for eight.
absolutely right. Absolutely right. Okay,
So I'm
let's
so
go back.
confused.
I'm so sorry. Yeah. No, that's good. Okay, so the short sleeve cost 5.
And
Long
then
sleeve
7.
cost 7. And the school paid 2,500. They sold the short sleeve for 8 and sold the long sleeve for 12. Beautiful. There we go. Okay, so now this one lends itself to the elimination method because I don't have a coefficient of 1 or negative 1, but this one could be pretty tricky in terms of, I mean, it's just not going to be pretty when you do this. So what I did is I multiplied the top row by -8, and I multiplied the bottom row by 5. And so I chose to eliminate the x value. So I got -40x minus 56y equals -20,000. And I hear the calculators going, and that's a wonderful thing to do.
I am sorry to interrupt. I need all the students that we're going to be helping in chapel to
Do tomorrow. Okay. All right, so then I got 40x plus 60y equals 21,000. And then I'm going to add those together and get 4y equals 1,000. I don't know why I did this, because now I had to go find the other one. I probably should have gotten rid of y, right? Because I wanted to know how many short sleeve t-shirts there were.
You saved yourself a step.
Yeah, I would have saved it. So then, if you plug it back in, I got x was 150. And something I would like to see us do is to move to a new level. On the OGT, they liked on the short answers where you write out your sentences. So what I would like us to begin to do from this moment forward is anytime you have a word problem, I want you to begin answering word problems in a sentence like this. It said, how many of the short sleeve t-shirts are sold? There are 150 short sleeve t-shirts sold. Okay, so let me repeat myself to make sure everybody heard me. On word problems, on quizzes, tests, homework, from this moment forward, I would like you to answer a word problem in a complete sentence. Okay, we're going to work on that because communication is so very important. The whole purpose of math is for you to solve problems in the world, but in order to solve those problems, you need to be able to communicate that solution to somebody. You know, you could solve it, but if you can't tell anybody what that means, it won't go anywhere, okay? All right, choosing a method. I've already stated this, but we'll just go over it again. The substitution method is convenient when one of the variables in the system of equations has a coefficient of 1 or negative 1. If neither has a 1 or negative 1, then use the elimination method. All right, example 4, solve a system with many or no solutions. So in letter A, since that x up here has a 1, let's go ahead and add the 2y to both sides, and we'll practice the substitution method. You could do it the elimination method, there's nothing wrong with that. But then let me plug it into the other equation. And I get 12 plus 6y minus 6y equals 8. Now the variable drops out, and I need you to write something down for me that this will help you. When solving a system of equations, and the variables drop out, there are two cases. Case 1, you get a true statement, and the true statement means there's infinitely many solutions. Graphically, that means it's the same line. Okay, so when solving a system of equations and the variables drop out, there are two cases. Case 1, you get a true statement. There's infinitely many solutions. Case 2, you get a false statement. And that means there's no solution, and it's actually the case graphically where you have two parallel lines. So this is very, very important. You've got your three situations. Most of the time they intersect in one point. But then you can have these two special cases. So back to our letter A, I got the variables dropped out and I got 12 equals 8. So what does that mean?
No solution.
There's no solution. And you are welcome to use this symbol here. Okay? Alright, next, try letter B. Do the elimination method, and I'll give you a head start.
Okay.
She would get one for that week, so there'd be 1,
two smiley faces.
So there's a box or an L or something?
Not a box necessarily, but it
Oh,
is
'cause this
an
is
L
L under it.
or a zero.
Okay.
So if you could, and then what I need you to do is when you're done, I need you to put a highlighter for the end of the week
Mm-hmm.
that
Okay.
says it's been done. So if you
Alright.
can do the smiley faces for this.
This is just for this class?
And if you're done, then,
Did you take that too?
yeah, it does go on the back and there's
Okay.
3 weeks. Okay,
Alright.
so if you have time, you can get 10.
Is that just these 2 periods?
Mhm.
Okay.
Okay, on letter B, I multiplied the top one by 7 and the bottom one by 2, and I got 28x minus 70y equals 56. Negative 28x plus 70y equals negative 56. Everything canceled and I got 0 equals 0. This is the true statement. So this means there's infinitely many solutions, but graphically what does it mean? It's the same line, isn't it? Okay, what I want you to do is turn to your warm-up section, and we're going to do a couple of extra examples. The first one, I want you to practice substitution. The second one, I want you to practice the elimination method.